Good morning and welcome to today's class. Today's class is a continuation of our previous classes on Surds. At the last class, I introduced Surds to you and we looked at the different types of Surds. We also looked at the rules of Surds, where I gave you about 3 rules of Surds, which says root x y is equal to root x times root y. And we also looked at root x divided by root y, which is said to be root x divided by root y, which can be simplified to be square root of x over y, and that can also be simplified to be root x over root y. I also informed us that root x plus y is not equal to root x plus root y, as well as root x minus y is not equal to root x minus root y. We said provided both x and y are positive. We looked at the basic surds, which I said root x is said to be in its basic form if x does not have a factor that's the perfect square. And I also showed you how to convert from single surd form to basic surd form, and how to convert from basic surd form to single surd form. I gave you examples, about 4 or 5 of them, on how to simplify obeying these simple rules of surd. I also left the class with an assignment where you are asked to simplify the following by reducing them to their basic surd forms. So in today's class, I shall be giving you the corrections of all these assignments which you were to do. So all I expect you to do is, if you have done them, kindly go through what I'm going to do at the moment and compare it with yours, thereby noting where you have issues. And if you discover there are some mistakes in mine, you can also use the comment section to interact with me. I also advise you to subscribe to this channel if you are yet to do that, as well as like our videos and share to your friends as you watch. Okay, let's take example 1. We are asked to simplify the following by reducing them to their basic forms. 1 says root 50. Now we are asked to simplify by reducing the following single surds to their basic forms. And just like I said, a surd is said to be in its basic form if the rational number under the square root sign cannot be expressed as a product of 2 factors where one is a perfect square. But looking at root 50, you discover that 50 can be expressed as a product of 2 factors where one is a perfect square, and that is said to be 2 times 25. 25 is a perfect square, while 2 is not. So we can express that as a product of 2 factors. So this becomes root 2 times 25, which we said is equal to root 2 times root 25. Since 25 is said to be a perfect square, it therefore means that we can look for the square root of 25, and this becomes root 2 times square root of 25 is said to be 5, and this can be simplified to be 5 root 2. So root 50, which is in its single surd form, can be expressed in its basic surd form as 5 root 2. B, we are asked to simplify root 125. All I advise you to do is carefully look at the rational number under the square root sign. If it can be expressed as a product of 2 factors where one is a perfect square, then that can be simplified. Otherwise, it is said to be in its basic surd form. Now, Another trick I would like to give you is this. For you to know if maybe you're not conversant with your squares and square roots, look at the rational number. Try dividing it by prime factors. By prime factors, I mean numbers like 2, 3, 5, 7. One of these will be a factor of that digit, of which the second may likely be a perfect square. So if I'm to consider this, 125 is not in its basic form, and 125 can be expressed as a product of two factors where one is a perfect square. And what is that? This can be said to be root 125 can be expressed as root 5 times 25. For 5 times 25 is still equal to 125. So this can be broken down to be root 5 times root 25. And when you simplify this further, this becomes root 5 times root 25 is the perfect square. So root 25 is said to be 5, and this is said to be 5 root 5. When you multiply this, I had to bring the rational number in front before the irrational number. So root 5 times 5 is said to be 5 root 5. C says root 98. Now try and simplify 98 as a product of two factors where one is a perfect square, and this can be said to be 2 times 49. So this becomes root 49 times 2. For 49 times 2 would give us 98. So this can be simplified to be equal to root 49 times root 2, which is equal to square root of 49 is 7, and square root of 2 is not a perfect square, so we leave it as the irrational part. So this can be simplified to be 7 root 2. So root 98 is equivalent to, in its simple short form, is said to be 7 root 2. D, root 147. Root 147 can be simplified to be equal to, root 147 can be simplified to be root 3 times root 49. So this becomes root 49 times 3, which is equal to root 49 times root 3, and root 49 is said to be 7, while root 3 is said to be an irrational number, and this is said to be 7 root 3. So I have been able to simplify root 147 to 7 root 3, which is the basic form of that. This cannot be simplified further. So we take the next example. E, root 200. Root 200 can be simplified to be root 100 times 2. For 100 is a perfect square. This can be simplified further to be root 100 times root 2, which is equal to root 100 is 10 times root 2, which is the irrational part, and this becomes 10 root 2 when you multiply. I hope you are following. F is root 490, and root 490 can be simplified to be root 49 times 10, which is equal to root 49 times root 10. This becomes square root of 49 is said to be 7 times root 10, which cannot be broken down. So this becomes 7 root 10 as our answer. So root 490 in its basic short form is said to be 7 root 10. G, root 243. Root 243 can be broken down to be, just like I said, if you don't know the perfect square you can generate from this, start by dividing 243 by 2. And 243 divided by 2 is going to give me 14 point something. So it's not going to be a perfect square, because a perfect square is not a decimal. Okay, so divide it by 3. When you divide this by 3, it's going to give us 243 divided by 3. 3 into 24 is 8. So this is 81. Is 81 a perfect square? Yes. Okay, so this can be simplified to be root 81 times 3. Okay, so this can be broken down to be root 81 times root 3. And square root of 81 is said to be 9 times root 3 is an irrational number. So this becomes 9 root 3. So 9 root 3 is said to be the basic short form of root 243. H, we're asked to reduce root 160, and this can simply be given as root 16 times 10. Okay, so this becomes root 16 times root 10. For 16 is a perfect square, while root 10 is not. This becomes square root of 16 is 4 times root 10 is an irrational number, and this gives us 4 root 10 as our answer. Question I says root 128. Root 128 can be broken down into, when you divide by 2, it gives you 64, and 64 is a perfect square. Now, what if you don't divide by 64? Let's say you decide to choose another number. Okay, 3 cannot go. Let's say 4. 4 into this will give us 32. Now, I'm going to do it in such a way that I may get the least perfect square. So this can also be given as 4 times this is 32. Yes. Now, in as much as 4 is a perfect square, 32 is not, but 32 can still be broken down. So I'm going to use, because most students may fall victim of this, where yes, you have expressed it as a product of 2 factors, but the other number can still be broken down. So you can still do it as same as somebody who got the exact perfect square, and both of you will still arrive at the same answer. So if you find yourself in such a situation, still go ahead and reduce it. This becomes root 4 times root 32, and you will tell me this is equal to square root of 4 is 2 times root 32. But 32 can also be expressed as a product of 2 factors where one is a perfect square. So I'm going to reduce it further to be, this is 2 times 32 can be expressed as, let's say 4 times 2. But I will now choose a bigger one, which is 16 times 2. For 16 is a perfect square. Okay, so this becomes 2 times root 16 times root 2. So this can still be broken down further into 2 times square root of 16 is 4 times root 2. And this is said to be 2 times 4 is 8. 8 times root 2. And this ends up giving us 8 root 2. This is same as somebody who goes straight ahead to say 164 can be simplified as root 128 can be expressed as 64 times 2, and this can be broken to be root 64 times root 2, which is equal to 8 times root 2, which is equals to 8 root 2. So you discover that whichever way you go about it, you will still arrive at the same answer. Next is root 500. Root 500 can best be simplified to be root 100 times 5. This is equal to root 100 times root 5, and root 100 is said to be 10 times root 5. This gives us 10 root 5. Don't forget to like this video as you watch. You can also share with your friends, and if you are yet to subscribe, please kindly click on the subscribe button and turn on the notification bell so as to be aware, also as to be notified whenever a new video is being uploaded. Root 40 can be said to be equal to 40 can be said to be 4 times 10 or 2 times 20, but 2 times 20, none is a perfect square, so we use the least perfect square, which is 4 times 10. So this becomes 4 times 10, which is equal to root 4 times root 10, and this becomes square root of 4 is 2 times root 10. Root 10 cannot be broken down further, so this is said to be 2 root 10. But watch out, if it can be simplified further where 1 is a perfect square, please kindly break it further. L says root 72, so this can be simplified to be root 72. Try and divide 72 into 2. If you do that, you get 36. So 36 is a perfect square, so this becomes root 36 times 2. For 36 is a perfect square, and this can be simplified further to be root 36 times root 2. And square root of 36 is said to be 6. For 6 times 6 is 36 times root 2. Root 2 is an irrational number, so when you multiply this together, it gives you 6 root 2. Please, on no account must you multiply 6 times root 2 to get root 12. Most students are always fond of making these errors or these mistakes. Is wrong. Okay, so this is what you get because they are not like terms. Okay, so this is a rational number while root 2 is an irrational number, so you cannot multiply them together to get root 12 unless these two, which you can multiply to get back root 72. So take note. That brings us to the end of today's class. In today's class, I have been able to give you the corrections of the assignment which was given at the last class. So in our next class, we shall be looking at the second objective, which talks about the application of rules of addition and subtraction of surds in solving surd problems. Now, this particular exercise enables you to see how you can simplify surds from their single surd form to their basic surd form. And maybe before the next class, I shall solve examples on conversion from their basic surd form to a single surd form. Don't forget to like our videos as you watch, where we encourage you to subscribe as well as to share the links to your friends and colleagues so that they too can also benefit from this project. Thank you for being part of this class, and see you in our next video. Thank you. Cheers.